We're going into our next session, and it's a privilege to introduce André Pienaar to you. You will see on his CV that he's a Pienaar originally, now living and working in both the USA and UK, but very involved in South Africa still. He also has acquired recently an interest in the Afrikaans media. So welcome, André. Ons luister graag na jou.
Baie dankie Dr. Elof, dis 'n voorreg om hier vanoggend by u te wees. En my onderwerp vanoggend is om te praat oor kernkrag as een van die sleutels vir Suid-Afrika se energiesekerheid. Einstein said that ultimately everything is energy. And that's all there is to it. He said if you match the frequency of the reality you want, you cannot help but get that reality. And this is not philosophy, it's physics. Although South Africa, as we've just heard from Mr. Oberholzer, has huge energy challenges and very serious energy challenges, I'm delighted to see that the people of South Africa, as represented here today, the Energy Indaba, has retained their own positive energy and the will and the determination to bring about positive change and the will and the determination to continue to work for positive solutions. And this conference is proof of that. And this is what will ultimately see us through this energy crisis. I want to say a particular word of thanks to the sponsors of this conference, the Afrikaner Africa Initiative, the Konrad Adenauer Foundation, Solidarity, and Liquid Technologies for enabling this positive change. In speaking about nuclear energy today, unfortunately, I can't promise easy and immediate solutions. Nuclear energy is not able to contribute quickly to the solution and the resolution of the energy crisis in South Africa. But nuclear energy is a long-term resource that can play a valuable and an important part. Nuclear energy is ultimately star power. By creating nuclear energy, we are really drawing down the powers of the stars to create carbon-free, always available, always on, affordable energy. Unlike coal power, which has been in use for more than 300 years, nuclear energy is quite a recent addition to our energy solutions. The first commercial nuclear plant was established only in 1957 in the US, and civilian nuclear power came to South Africa in the 1960s. So although coal has been in use for more than 270 years, nuclear is quite a recent addition. And in the application of nuclear power over the last 60 years, we've had to come to grips with many of its limitations as well as its potential. But we've now definitively established that the use of coal is not good for our very fragile blue blanket, our atmosphere, our climate, that enables complex life on our planet. And therefore, we have to find clean energy resources. And nuclear energy is a complementary energy resource to renewables. Nuclear energy itself is in the process of being transformed to a form of renewable energy, because at the moment we use nuclear fission, which involves the splitting of atoms. But in the future, and certainly within our lifetime, we will be able to fuse nuclear atoms through nuclear fusion, and we'll be able to draw on deuterium and tritium, two of the key components of hydrogen, which we have an abundance of in our oceans, to produce nuclear fusion. And this will create the cleanest form of energy known to human civilization with no waste. And that's on the horizon. In South Africa, nuclear energy continues to play a very important role in providing energy to the country. Although the Kubrick energy plant produces only 5% of South Africa's total energy needs, that 1,940 megawatts is one of the most reliable and cheapest forms of baseload energy for the country's economy. And therefore, the transition which has been described by Mr. Oberholzer to extend the life of this plant for another 40 years is a very important step in providing for South Africa's energy. The reactors that we have at the Koeberg plant are generation 3 reactors. And fortunately, now we also have on the horizon new forms of nuclear innovation, like small modular nuclear reactors. This technology emanates from South Africa in the form of the very well-known pebble bed reactor technology, in which South Africa was a world leader. In fact, the pebble bed project, which started at the University of Northwest, employed more nuclear engineers for the build of an advanced nuclear reactor than anywhere in the world, and already in 2006 was under contract with the US Department of Energy to establish the first advanced reactor demonstration model anywhere in the world, and the first site and location for this reactor was already identified by 2008. Unfortunately, this project was discontinued in 2010, 2011, when the government decided to make it a matter of policy to go back to generation 3 reactors. And so South Africa lost the benefit of almost 20 years of innovation. The pebble bed reactor program was really one of the fruits of South African democracy, having been started in 1994, and the South African government invested more than $1.3 billion in being at the cutting edge of this innovation. If the project wasn't discontinued, South Africa would have been the first country in the world to have an advanced small nuclear reactor. Today, this innovation is being led by the US, and a company in which we are invested in, Energy, led by Dr. Cam Ghaffarian, has the benefit of some of South Africa's greatest nuclear energy minds, like Dr. Eben Mulder and others. The advantage of small modular nuclear reactors is that they are mobile, that they're always on, that they're safe, and that the reactor models cannot melt down, that they do not pose any proliferation risk, and that they can have niche applications, like making contributions to medical science and fighting cancer. And this creates a complete paradigm shift in technology. Whereas in the past, nuclear energy was the limited domain and resources of governments and states, the private sector can now play a meaningful role in helping to finance small modular nuclear reactors and apply them for industrial and other purposes. It's somewhat like the evolution of computers. In the 1960s, mainframe computers was an exclusive research resource for governments until the onset of desktops. And then it became the domain of private sector innovation. And today, private sector innovation in the technology space outpaces that of government. And we're going to go through a very similar process in the nuclear sector. And this creates new possibilities to apply this technology for South Africa and Africa's requirements. South Africa has been a leader in the nuclear industry, not only worldwide, but also in Africa. Today in Africa, there's a very serious interest in nuclear energy and nuclear power, and more than 30 African countries have nuclear programs and are seeking to access nuclear energy and apply it for their growing needs. As we know, more than 600 million people in South Africa still do not have access to reliable energy, and more than 80% of businesses get disrupted through frequent energy disruptions. And South Africa and Africa's energy needs will more than double by 2050. And so nuclear can play a very important role in helping to meet this demand and act, as so many of the speakers said this morning, to help alleviate energy and uplift people out of poverty. And so South Africa and the Western Cape has an opportunity here to help meet Africa's energy needs by making its nuclear know-how available to the rest of the continent. South Africa's nuclear leadership is not only in the crown jewel of Eskom in the form of the Koeberg reactors, it's also in the fact that the country has well-established regulations around nuclear energy and the safe application of nuclear energy. It has well-established regulators. It has several universities who produce nuclear engineers who are at the cutting edge of nuclear innovation. And it is a trusted member of the International Atomic Energy Authority. And so South Africa can play a role not only in meeting its own energy needs, but it has all the constituent parts of a nuclear ecosystem that can help meet the ambitions of Africa. Many African countries at this stage are looking to source their nuclear energy from antiquated nuclear reactors being provided by Russia and China, often at a huge premium, and in the wake of it follows a great deal of corruption. And South Africa can provide, in partnership with other international partners, by replicating the model of the success of the PMBR development, an alternative solution. At the recent meeting of the International Atomic Energy Agency in Washington, D.C., Japan and the U.S. announced a new program called WeCan, which is specifically focused on helping African countries access advanced nuclear innovation. WeCan stands for the Coalition to Access Advanced Nuclear Innovation, and Ghana has been one of the first countries to sign up to this program that's being sponsored by the US and Japan. And similarly, the US have launched the Foundational Institution for Responsible Use of SMRs as a new program to enable African countries, developing countries, to access advanced nuclear innovation. The willingness of the US and other industrialized countries now to share this technology and to make it available to help use nuclear energy as a form of clean energy to uplift people out of poverty, to form new partnerships with developing countries is very promising and opens up new opportunities for the South African private sector. Currently, the mining sector takes up about 30% of Eskom's energy supply and industry 52%. If the South African private sector is able to adopt SMR technology to provide energy to mines or to industrial plants, we can release this capacity back for national usage and for residential usage. And so this SA Inc. coalition, which Mr. Uber also envisaged for South Africa, could be equally applicable to bring nuclear innovation to South Africa for our energy needs. However, as I said, nuclear doesn't provide any short-term solutions, not perhaps even medium-term, but for the long term, it holds great promise to meet South Africa and Africa's energy needs. And as President Mandela said, when you have a big challenge, the best you can do is to point your head towards the sun and to keep moving your feet forward. And this is what we will have to do to meet these challenges. Thank you.
Great. If you just stay there and we have some time for discussion. André was short and sweet, so we made up some time. Thank you. Questions or comments? One here and one there. Let's give this gentleman a chance first, then this.
André Christian from SPAR, thank you very much for the insightful information. The way you project energy potentially can become commoditized at a rapid rate if it becomes very cheap, the way you are explaining it to us. For businesses and investment to reach that point, I think the investment potentially could be 50 years out, like you said, or 30 years. But we are heading towards this storm where there's so much effort put into this energy crisis that there's going to be a fight for the commoditization of energy. How do you see some of the investments and the TCO models, return of investments, for some of your initiatives and using nuclear in the continent?
That's a really good question. I think the first challenge is to get everyone smarter about nuclear energy's potential. The nuclear energy industry, unfortunately, for many years suffered from reputational challenges. Even though the overall safety record of the nuclear industry is better than certainly the oil and gas industry, and certainly better than the mining industry, it still suffered reputational risks. Some of that was because of geopolitics. Today, Russia dominates the nuclear supply chain, and it attained that position in part by trashing the reputation of other nuclear operators through disinformation. But I think the First challenge will be to get everyone, particularly the private sector, smarter about the innovation that's happening in the nuclear sector so that people can see and understand the solutions that are applicable. I think the second challenge is how do we keep the nuclear sector, which is a crown jewel in the South African economy, thriving. And I think in part by developing products and services for export to other markets across Africa. And that's an opportunity for the private sector. It's an opportunity for the private sector to bring together the finest minds in the sector and provide products and services to other markets who are willing to move faster and to accelerate the application of nuclear energy, because in part that's about regulation and that's about political will and determination to apply new forms of nuclear energy.
Thank you. Mr. Cameron.
Question. If we look at the...
Sorry, I know you missed the Cameron, but just for the rest of the...
Okay. Edward Cameron, Flint Rock. Just a question regarding the technology readiness of all of these solutions. As you've alluded to, there has been reputational aspects and the corruption aspect. So I think even in South Africa, I would believe that a lot of people just don't know about all these advantages, all the progress, all the positive things, the role that nuclear can play, and I believe it can. But just regarding technology readiness, can it play that role today, or is there a window ahead before it will get to the point where it can compete in terms of readiness with renewables, gas, anything like that?
That's a great question. So nuclear energy doesn't replace renewables. It's complementary to renewables, and it's complementary to gas as a transition resource for clean energy. But the technology that's been used in small modular nuclear reactors is the same technology that have been applied safely in submarines and aircraft carriers for many decades. And the reason why SMRs could be deployed in submarines and in aircraft carriers is because there's no meltdown risk. So even if there's a kinetic event, there's no risk that the reactor will melt down. And something which has been the domain of the military of a few countries is now being made available for civilian purposes all around the world. And it's almost like the Atoms for Peace moment in President Eisenhower's great speech in the 1950s to the UN, where the US pledged to use its nuclear weapons know-how for civilian purposes. That's now taking place with SMR. So the technology works. It's safe, it's applicable, and there are a whole range of projects underway all around the world to bring this technology to bear. And since so much of this know-how innovation originated in South Africa, it would be a great tragedy if the country doesn't benefit from it. In fact, there's a $1.3 billion investment that sits behind this technology that was made by the South African taxpayer that must come back to this country to benefit the country and its people.
Can I, while we wait for another question, just ask the one question that I've been confronted with, André, and that is the financial viability. Is there a possibility that the small nuclear reactor technology will become cheaper? Because at the moment, from what I know, it's fairly expensive.
Well, here's a South African project that will cost in the range of $400 million to establish an SMR. Now compare that with the $80 billion that Mr. Putin wanted to charge South Africa for his reactor. There's no comparison. I think what will happen is that the first SMRs will be applied by the private sector. They will be used by mining companies and by large industrial companies, by companies that are building digital infrastructure, and that some of that will be used to release energy capacity on Eskom back to the nation, back to residents, or that folks that live in the vicinity of an SMR will have the benefit of surplus power. And I think that's a natural way to bring that to bear, and it requires a new partnership between the private sector and the government around the development of nuclear energy. And I think this is what nuclear innovation has enabled. It's really opened it up to the private sector. Last year, about $5 billion were invested by the venture capital industry in the development of nuclear innovation, and I think that speaks of the opportunity that there is for the private sector now to play a role in the development of this technology.
Thank you. Sir?
Johan Marie Ebosch Stellenbosch. The whole question of public opinion has been referred to quite a number of times already as far as nuclear power is concerned. And my gut feel is that there should be a very specific strategy to inform the general public about all the options as far as our energy crisis is concerned, but then most specifically also as far as possible nuclear solutions are concerned. And I think that is maybe necessary for two reasons. I'm making a statement now, not asking a question. And the first is, of course, to really inform the public fully inform them so that intelligent and decision can be taken in terms of what the future shall hold for us. But secondly, also to encourage and make possible people's commitment to invest in this. If we think in terms of many, many years ago when ISCOR for the first time became a possibility, the trust that was exhibited by the general public in taking up shares in this new enterprise, which was such an important also element of making that as a project successfully. So your guidance may be on how do we go about informing the public and preparing them for their role also, maybe later as shareholders, investors in nuclear power.
I think advanced nuclear is one of the attributes of advanced nuclear and small modular nuclear reactors are complete transparency around the science, around the engineering, around the cost, and around the application. Whereas legacy nuclear that emanated from the first development of nuclear weapons and there was the domain of governments was often characterized by extreme secrecy. Advanced nuclear is characterized by openness and transparency and community engagement. And I think South African academic leader de Kock wrote about this in recent weeks in the Burger, about the importance of getting community buy-in and community governance and community making informed choices. And I couldn't agree more with that point of view. It's very necessary. And the wonderful thing is that nuclear science is such an exciting domain of study because it's really about the study of our universe and it's really about the study of our sun and our solar system. And so this is a really exciting area for people to learn more about how energy works, how our sun creates energy, and the next phase of innovation, nuclear fusion, that's on the horizon. That will be the cheapest and the cleanest form of energy known to human civilization. So this is a terrific area to talk about and to educate people about and to give people access to and insights to. And it can create jobs. Even today, the nuclear energy industry in South Africa maintains some of the most valuable and highly skilled jobs in the country. And those jobs are worth preserving and expanding. Nuclear is going to play a crucial role in not only in helping us solve the problem of climate change, but in creating new jobs and solving some hard problems like curing cancer, but also helping us with for example, space exploration. Because nuclear is the only other source of energy that's available other than the sun when you're in space. And so, for example, in the successor to the International Space Station, we'll have a small nuclear reactor on board, in the same way that a submarine has a small nuclear reactor on board.
Thank you. You know, just I also heard that the Department of Energy in the US has certified nuclear as green.
Not only in the US and Canada and in Europe as well. There's a consensus that nuclear energy is a form of clean energy because it doesn't create any carbon emissions. And the problem of waste with small modular nuclear reactors becomes very manageable. And with nuclear fusion goes away entirely.
Okay. Two last questions, Werner and then Christina.
I think that actually spoke to my question that I wanted to pose. My colleague Christoph Kleiber from Konrad Adenauer Foundation alluded to the fact that in Germany in the 1980s, you know, the Green Party was actually a result of the anti-nuclear movement. And the fear in Germany was not only about accidents, that would be devastating, like Chernobyl, but also about what happens to the waste. And I think you quite rightly say, in the sense with carbon footprint, it's maybe called a clean energy, but nevertheless one has to see what is a product, the side product, and what happens to the byproduct, and how dangerous is that, and where will it be stored, and what about the next generation. I think, what we're looking often is, the generation now and maybe the next generation. For human beings to think, in hundreds of years and thousands of years, that's not in our nature. But I think it's a question that we should, ask ourselves, what happens with the waste?
I think that's a really important question. I recently spoke at the Linda Foundation meeting, which is the annual meeting of Nobel Science Prize winners and young scholars. And after I spoke, so many young German scholars came to speak to me, and I think what's happening in Germany is very interesting. Firstly, the reality of the situation. The German government decided to extend the life of its existing reactors because of the way in which the Kremlin is weaponizing energy. But secondly, if you look at small modular nuclear reactors and nuclear fusion, that innovation in Germany is thriving. And the reason why it's thriving, and it has strong support from the German government through a number of grants, is because it solves the problem of waste. In the case of SMRs, not entirely, but it does completely change the challenge of waste management, because the enriched uranium is encased in a graphite ball and can be stored on site. In the case of nuclear fusion, it will solve the problem of waste entirely, because nuclear fusion doesn't produce waste. I think we must bring an historical perspective on the application of nuclear energy. We've only had 60 years of applying this energy in human civilization. That's not a very long time. We applied coal-based energy for 300 years before we really came to the conclusion it damages our climate. And I think what we've seen over the last 60 years has just been the first chapter, the first human experiment of how we can unlock the power of the stars to solve our energy needs on this planet and beyond. I think in the next chapter, SMRs, and beyond that, nuclear fusion, I think we will make a great deal of progress that will really make this a sustainable long-term solution that helps protect the planet.
Last question, Bernard.
Dr. Teens, Werner Riemann van die Solidariteit Beweging. André, I've just got a short question that's in relation to the nuclear initiative. When we think in nuclear terms, we think large scale, we think government policies. Are there any examples in the world that is relating to community involvement in nuclear, and how communities can in a way see to themselves in relation to energy requirements?
Verder, dis 'n baie goeie vraag. In die Washington State in die VSA, waar X-Energy die eerste klein kernkragreaktor gaan bou, is dit 'n direkte resultaat as gevolg van die wetgewing wat plaaslik uitgevoer is in Washington State, the Clean Carbon Energy Act, wat vereis dat al die energie in Washington State van skoon energiebronne af moet kom. En wat hulle uitgevind het is dat hernubare energie as gevolg van ekstreme weerpatrone nie gereelde en volhoubare energie kan voorsien nie. Dit voorsien aan baie van die behoeftes van die staat, maar nie 'n algehele oplossing nie. En dis hoekom hulle besluit het om 'n klein kernkragreaktor te implementeer. En dit was 'n plaaslike besluit gewees wat geneem is deur die staat en deur die 3 stede waar die klein kernkragreaktor geleë gaan wees. So dit was 'n plaaslike versoek gewees wat toe geïmplementeer is deur die Departement van Energie op 'n federale vlak. And we see that more and more. We see more and more cities, governors, mayors, local communities saying we want to have this form of energy and innovation for purposes of economic development locally. Can we have it? How can we access it? How can we gain access to it? And also very remote rural communities, because in addition to small modular nuclear reactors, you can also have micronuclear reactors which produce about 8 megawatts of energy, which you can transport with a truck or a plane to a small rural and often a remote rural community for economic development purposes, and to your point about agricultural development.
Thank you, André. André will be with us for the rest of the day. You're welcome to ask him any questions.
One last thought. I can see a small modular nuclear reactor in Cape Town's future.
Yeah. Well, I see it with the Royal Mobile family.